So my name is Mishra. I go by my last name. I also work with Luke. We work on the Hootsuite Kubernetes platform. And yeah, so I'm mostly focused on infrastructure, where Luke is more focused on application delivery. And what I'm going to talk to you guys about is making his app kind of global and how you do that in Kubernetes and what's the standard right now in Kubernetes. Huge disclaimer, this is super beta. I just got it working like a couple of hours ago. So yeah, it might not work. So, it might not be really global, but I can promise you it'll be interesting. And it's pretty short. Like, I'm not going to waste a lot of time in explaining a lot of things. Luke's done a great job explaining all the different primitives that Kubernetes has to offer. I'll kind of represent them in a way that's more like kind of higher level kind of in a way. Okay, so we know about this one Kubernetes cluster. If you, let's say you get like super excited after this talk, you go back to your companies, you start using Kubernetes, that probably won't happen. But if you do, and you're using GKE, and then you have this, like, let's say in his case, that app running in the GKE world, and you get really good at it, right? Like, and you have like hundreds of services running on it if you're at that scale. In our case, eventually, hopefully we'll have 30, 40 services running on Kubernetes. And yeah, so you get really good at like managing this one cluster and understanding all the different Kubernetes components, and you're pretty happy at this point. So at what point do you actually make a decision, let's say based on your customers or whatever, you want to present them a global application? So today, like startups, day one want a global application. They want, oh, my app that is in the app store should be available everywhere, right? And how do you make that possible? So years ago, only Google and Facebook and big companies like these would actually be able to execute on that like in a short period of time. Then unless you have like point of presence around the world, you cannot realistically invest in that kind of money. So Google actually gives you a very well knit, fast fiber network across the world. Also, the point of presence are pretty much everywhere in the world. And how do you make use of that in the Kubernetes world? So basically, this talk is about like how do you use Kubernetes in a global scale, right? So that's where Kubernetes Cluster Federation comes in. So who's heard of Kubernetes Cluster Federation? Highly unlikely anyone's, except like few people. Okay, so this is big three words, I guess, in a way. But I'm going to try to like simplify it to an extent that, as I said, it's a very like futuristic talk. So this is not realistic for like many companies. Like, you probably won't need this, but this is pretty cool that you can do that. Like a person like me or someone who's like not dealing at a scale of like hundreds of services can actually do that with effectively not much like money, basically. So let's say you have this one cluster running in US East, and it's pretty close to us, and we are able to operate it really well, as I said. Now, let's say your business demands like, okay, we're expanding to Europe, Asia. We want this application to be closer to our users. Then you go to the GKE console, as you saw, click button, deploy, choose US Central, choose EU, choose Asia, and you have identical isolated units of these clusters running, right? So the beauty of this is that these clusters, which what Luke was talking about, individual clusters is actually production grade, 4 nines or 5 nines availability. I don't know how much the availability is in GKE, but pretty high availability, and they're built for scale. So each one of them can actually handle a lot, right? And let's say you create 4 of them, right, in this case. So how do you operate these now, right? So that application that we created, what was a GCP Meetup? Let's say that GCP Meetup application had to run on each of these clusters. So what you could do is what Luke did, kubectl, point to one cluster, apply. kubectl, point to the other one, apply. And you can write a really nice for loop script, bash script, and that might work. What happened? The TV turned off? Oh, no, that was good. The laptop was good. I think the TV turned off. I don't know. It's like a really sophisticated system. I think the TV is off, right? Power switch on the TV? Oh. Red light's on, so it's got power. What happened? So what's up?
Call tech support.
As soon as I was going to go to the actual climax of the thing, it just goes off. That's right.
That's true. It's hot enough in here. Maybe it just turn itself off.
The heat. Sharp. Okay, so where were we? Okay, so let's say you had to deploy that application every cluster around the world. You could just write a simple for loop bash script, right? You can glorify that bash script and go in and just like run these applications all out and in every one of these clusters. And you can use them. You can use a service primitive to access them. You can get load balancer on top of that. It'll just work, right? But how do you make it so that your users actually, it's like easy for them to access the application wherever they are, and you have a single point of entry to them, right? So in the very Kubernetes way, the way Kubernetes thinks about this is that, okay, let's just put an API server on top of this as well. So you have like API server, API server, API server, API server, and then you have one on top, right? And let's say you have like multiple of these like federation cluster, you can put another API server on top. And that's how they look at it. And no one's doing that crazy stuff anymore, but it was proposed, but no one is now. But the Federation API is basically a simple lightweight API that sits on top of these other APIs, and then you can host that API in any one of these clusters. So the idea is, so now you guys might be thinking, okay, so what if it's hosted in US Central and US Central goes down, right? So what happens to all the jobs that are running in each one of these things? They'll just keep running. Nothing will change. Only you won't be able to submit a federated job, basically. So you can still submit individual jobs to these clusters, but you lose the ability to kind of submit a global job, which is fine, right? You can alert on that, go in, fix it, and it's good. But then remember, like the way this API server is actually running on these things is actually as a pod as well as a deployment. So it'll be HA, and Kubernetes will make sure that it's running, and if it fails, then it'll restart based on the health checks. So that's good, right? So we have an API that we can access. So what you end up getting is actually a global computer, right? Which is super cool, right? Like you go back, you look at like that one computer, like which Luke was kind of interacting with, which was made up of 3 nodes, super highly available, has its own data set. And now you have like all these ones kind of making kind of feeling like one computer, which is super awesome, right? So let's see what this looks like. And in terms of like the cluster federation, federation, as I said, is super like beta, like it's really not being used a lot by a lot of people. So in terms of like the primitives that it exposes, it's pretty minimal. So you don't even get deployments. You get replica sets, and I'll talk about them in the talk. So you get things like events, secrets, daemon sets, config maps. These are all primitives that help you build your application. But this is enough to kind of run a global scale application. So let's do the demo, and it's mostly hands-on demo. So hopefully it works out. All right. So I'm trying to use like no terminal. I'm trying to use all Google stuff today. So we'll use Google's Cloud Shell. What is this? Can I remove this? Disable. No. Okay. 1 second. Sorry, guys. Okay. Okay, I'll reconnect. All right, so I'll be using Google's Cloud Shell, and Google Cloud Shell is basically, you enter Google, and then, the first thing you say, how do I use everything in CLI? It kind of gives you a lightweight container, and it spins that for you and keeps your session and stuff like that. And basically the ease of usability comes from being able to access all your Google resources without actually configuring any config, kubectl commands and things like that. It has it already. So here, what I'll be using is, this is all open source, by the way. So I'll share this out at the end of the slide. So this tutorial is fully open source. You can try it. So this tutorial is based on Kelsey Hightower, which is a developer advocate from Google. He's done this tutorial of how to create actually a federated cluster. You can go through this, and you'll get a fully federated service, federated cluster, which will look like what we're doing. Actually, I'll just move this down here. There you go. Okay, so you'll see this fully federated service that'll have basically these clusters. So in this case, we have Asia, Europe, US Central, and US East. So we have 4 clusters. Each one of them is pretty much the same what Luke was talking about before, but they're independent right now. They're independent units, right? And then what federation kind of gives you is what I said, that global computer, right? So let's actually query that, right? So let's do kubectl. So right now I'm interacting with the federation API, and I'm not interacting with individual clusters. So the first thing we go, and basically prerequisite is basically make sure that we are pointing to the federation cluster. So we go here and we say, I want to use the federation cluster context, and we switch to that, right? I had to do nothing. I go in and then say list all clusters. I'm copy pasting commands. So look at my skills at copy pasting. It's really good. Look at this. Okay, so you do kubectl get clusters, and you see there's like 4 clusters that are ready, which is similar to what you see in the console, right? Okay, so now we're ready. We have all these clusters in our pool of instances. So the next thing we do is, okay, I'll put this here. Yeah, the next thing we do is list all the pods across them, right? So now here's where it gets beta, right? In this case, you actually don't get the pod primitive, so you can't be like kubectl get pods, and that'll give you pods across all the clusters around the world. That doesn't happen. So you write this amazing bash for loop, which is pretty straightforward actually. So you go in and you say, okay, these are my clusters. You just inject the cluster variables, and you say kubectl get cluster. Oh, sorry, kubectl get pods across it. So in Asia, I have hopefully nothing, okay? In Europe, I have nothing. I haven't created anything yet, so hopefully that all works out. It's a little slow because we're actually making calls to the API servers across the globe, right? So here, one in East is pretty fast, and Central is, okay. Okay, so there you go. So you have all those, you're able to list all the pods across everything, and there's nothing running. So here's where I'll start creating stuff, right? So here's where we'll take Luke's app. So let's see where that is. So Kubernetes, this name is so long, I regret it. Look at this. Look at this. Okay, so replica set, right? So what a replica set is basically another one of these primitives. I know there's too many of them, and it does get a little overwhelming, but then they're pretty simple to understand. So what replica set is basically, you remember deployment from Luke's talk? So what deployment does, when you create a deployment, it actually creates replica sets in the background and manages these replica sets. So when you go from one version to the other, it basically it scales up one replica set and scales down the other replica set. So in this case, I'm actually using the replica sets directly because Federation API doesn't let me use the deployment primitive right now. So it's pretty much the same if you look at the code. Can everyone see this, by the way? At the back, you good? Okay, yeah. So in this case, I'm just calling the app GCP Meetup Global because we're going to do a global deployment. And I'm going to just run one of these replicas, right? And then I'm going to label it the same way. And I'm going to use Luke's Docker image. And then I'm also going to pass the node name. And here's where the node name becomes interesting. Here's where you kind of see where the node's actually running, where the app's actually running. All right, so let's go back to the tutorial. And we'll create this replica set. All right, so it says created. So let's see if it actually exists. kubectl get replica set. And it says desired 1, current 0, ready 0. So the reason why it takes a little bit, like if you remember, like when Luke was creating containers, it was so quick because he was interacting with one cluster. In this case, you're interacting with like a pool of instances across the world, right? So it takes a little bit to converge the state. So in this case, what Kubernetes has done is basically deploy this thing and told our global computer that, hey, run this one instance anywhere in one of these clusters, right? So we don't know where this is running right now. So let's see where this is actually running. So let's do a pod across all of our clusters. Let's get pods across all of our clusters. So let's do this. Okay, so Asia, it's not running there. Okay, so it's running in Europe West somewhere, right? And you can actually control this. You can say, hey, like if I just specify one, then weigh US more because I have more US customers. You can also say like when I increase when I scale up, then scale up in US first in the morning, and then scale up in Europe in the evening, and so on. So it's all customizable using annotations. So that's too detailed, but I have this one thing running, right? Okay, so the next thing is like, how do I actually get to this thing, right? I want it to be exposed as a global service. How does that work? So again, I'll just use the service primitive like you saw in Luke's presentation. So I'll go back and I'll show you what the service primitive looks like. Get ready, guys. It's exactly the same, actually, if you look at it. In terms of the service name, it's exactly the same. The selector is, again, the global selector. And then the target port is 80. And then the target port is 8080, and my port is actually 80. And then all I'm adding is this thing called node port. And this is on purpose. The reason why I've added this is for completely demo purposes to make sure that I reserve a port on these nodes so my demo doesn't fail. But you actually don't need to specify it. Kubernetes will assign you a node port and it'll just work. So, okay, so in this case, what the node port type means is that when a service comes up, Kubernetes will expose that service using a port on the actual node rather than giving you a load balancer in Google Cloud Compute or a load balancer ELB in Amazon. It'll actually give you a node port on the actual node, and you can hit the node on that port and you'll be able to access the service. So in this case, I'm doing that so that I can actually create a global load balancer on top of this. So here's where things get a little bit interesting. So let's create the service. Let's go in, create this thing. All right, I said it says created, so let's do kubectl. I always like to check whether things are running, which I think we all should be doing. It says, okay, it says there's no cluster IP, there's no external IP. It says port 80, and then it says the mapping is to the node port. Okay, so let's just see like where are the services created. So let's do a describe on the services. No, actually, let's do a get on all the services across the globe. So yeah, here you'll see it actually created the service everywhere. So I actually specified one place, but it actually created in all my clusters, right? And which is what you expect. You want everything that you're operating on the Federation API to kind of replicate over to all the different APIs. Okay, so now that service is in place, I'll actually do a get rather than this describe because it's a lot of output. So you guys can actually see what's happening here. Get, okay. So yeah, you see that the service is running, and then the ports that it's exposed on is actually 30,015, which is what I specified. All right, we're good to go now. Next. All right, here's where things get the global scale. I know you guys are waiting, when is this thing like actually going to work and things like that. Okay, this is it. So here's the three things that you need to do to create actually a global accessible service. The first thing is to actually assign that global IP, which is accessible around the world, on Google Cloud Compute. And this is like what the one-liner that lets you do that. I'm just naming the IP to be GCP Meetup. This is pre-provisioned because it takes 5 minutes. That's why to save time, I've already provisioned this. And then create a firewall rule that allows that load balancer to access your cluster, to access your network. And that's it. And this is the side range that it operates on. But the key point is in the future version, this will be more stable. So you won't even have to do this. You just say kubectl, create the service, and I want a static IP attached with it. And it'll give you that without any issues. Okay, so we'll create, the ingress is already created. So let's actually see, go back. So kubectl get ingress, actually ingress. That's a short name. I just want to show everyone that's actually ingress. Okay, here we go. So here's it says the address is 35.201.87.50. So this is my global IP, and it's listing on port 80. So what I expect is that one application that was running in Europe, only in Europe, even though if I access this from Asia or anywhere else, it'll actually redirect everything into Europe because there's no other application pod running in any other cluster, right? So in this case, what we'll do next is, okay, this is fine. Let's actually access it. Now this is where the demo gods are, please be with me. Okay, here we go. So let's see if this actually works. So this is the Google Cloud Load Balancing console. Okay, so here you see this is the global load balancer that Google created. Ignore the second one, but this is the one that we wanna explore. And then we see the backends, nothing is healthy, which is what I expected, because this demo is gonna fail. Okay, let's see. Come on, please work. Okay, it takes a little bit. Okay, actually, let's see. All right, guys, let me see what's going on. Here's a live demo debug right now. Let's go back and see where these pods are running. Actually, let's first see the federation. Okay. So ingress, yeah, there's a lot of output, ignored it. Okay, here, it says it's created the ingresses, so that's good. 201.58 global, okay, that should be the one. I think it'll just take a little bit here. Yeah, that's a good question. Let's just see. Okay, here. Okay. Okay, it's running. That's good. Okay. Actually, let's just create like services. Like let's just make it available everywhere. Okay, so I'll just scale this application to 4 so it's available on all 4 clusters. I was just trying to be cool and show you guys that it's running. Okay, whatever. That didn't work out. So, okay, so let's go down. Let's just scale it to 4. And then that's what you need to do. It's pretty simple. You say kubectl scale my replication set. This is the name of my replication set. I want 4 replicas, and it scaled it, right? So let's do get replication set. It says desired 4. It'll take a little bit to give me this replication set like running everywhere. So actually see if we have this running everywhere. Okay, so it's running pretty much everywhere, which is what we expect. Hopefully, now There we go. Okay, so we have US Central healthy, right? So now none of these other things are healthy. I don't care. There's one healthy backend, which is what I'm going to play with now. So we go in, and then we get this global IP. So we say, oh, sorry, we get this global IP from here. Say kubectl get ingress, and then get this IP. And I'm going to go here. I know it says that. I'm going to try to hit it. Okay, so here, this is a global IP that I've accessed from where? From West, right? We are in US West. And then, well, if we're in Canada, that's right. We're in the West Coast. So it's now redirecting it to the one healthy backend, which is in Central, right? And you see, if I refresh, the expectation is that, this increases, and this is working exactly the same way as we expect it to, which is awesome. Now, what if I were to hit this from Asia or from somewhere else? So let's do that. So here I have, if you guys can see, I have machines from around the world. So I have one in Europe. I have one, this again in Google Cloud Platform. It's pretty easy to build. One in West, one in. So I'm just going to A/B Apache Bench, and I'm going to throw a lot of traffic on it from everywhere. So here we start our benchmarking. Okay, so it's doing some requests. And let's go back to our cloud console. And then let's work with a health check. Now, actually, I'm seeing all the backends are actually healthy. I just had to wait, guys. It's okay. It just took a little bit. So if I go back here, now I should see the traffic flow through these backends. So Asia should flow to Asia. North America should flow to North America. Europe should flow to Europe, right? This is where I hope my demo works. And if it doesn't, then you guys can just tweet about it and be like, this guy just promised us this global application and it didn't work. It takes a little bit. This one takes a little bit. This one I expect it to take a little bit, like a minute or something. Okay, come on. Okay, let this, I'll show you something else. Distract you guys. So let's go back. Go back to GeoScreen. Okay, so we're going to see the screenshot of this, from different parts of the world, from India, London, and San Francisco. Oh, actually, I should do hello, right? That gives you the output. Okay, so let's do hello. And then what was it? Greeting equals hey. And I'll capture the output. So let's see. Come on, okay. So let's see what the Bangalore one says. This one's in India, so this should go to Asia. And if it doesn't, you guys can tweet about it. So you can see it's actually routing to Asia. I don't know if you guys can see that. You can't see that. Okay, hold on. I'm gonna zoom in. Okay, that's the zoom in on Asia, right? So this is exactly what we expect. Now let's see the London one. That should go to Europe. That one's going to Europe as expected. You go back to, I'm distracting you guys right now. This is awesome. Okay, go to US. Now you can see it's going to US Central, which is what we expect. Okay, let's go back to that cool, oh, there we go. So now you see each an individual request from every one of those instances from around the world is actually being routed to one of our cluster backends that's running in Kubernetes, across the world. And then we're controlling it using one federation API. This is the promise of federation. And with this, I end my demo. That's it. Thanks, guys. Questions? I know you guys have a lot of questions. Oh, I get out of the way then.
What's the logic for that? Because you have a global IP there.
Yes.
That everyone is hitting.
Yeah.
Where's the logic that says that this should have this location?
It's controlled by Google. So yeah, exactly. Geolocation. So they have a little bit more sophisticated way of kind of figuring out where the users are. They don't talk about it. It's more than just using IP range and then kind of something smarter than that. You expect that. But they've had this for a really long time. But the Kubernetes integration was something that they worked on, and which I think they're the only platform right now. Even Amazon doesn't have it right now. Of course, Amazon doesn't because they don't have a container engine that supports Kubernetes. Microsoft doesn't have this right now. Azure doesn't have it right now. So they're the only ones that have this, and it's pretty nice. If you need it, it works. In terms of now, you'll ask someone might ask in terms of what about state? Because now if we had to replicate across the world, how would that be? And they have something called Spanner. So there's also a paper on Spanner. Spanner is a globally ACID compliant database that is globally atomic, and it's crazy. It's really cool. It scales really well. You should read the Spanner paper that they talked. They kind of go through all the ins and outs of it, and then they have publicly available on Google Cloud Platform. So if you want to scale your database, you can use that too. I totally sound like a Google Cloud person, but I'm not. It's just so cool. And we don't use that at Hootsuite, you know, like I wish you could use it. It's so cool.
Yeah, following on from that with DNS, kind of if you wanted to have like eu.mydomain.
Yeah, so I'll show you. Yeah, so actually, like what I didn't show you is like the kubedns, which Luke was talking about, which is accessible locally inside the cluster. When you create a service, you get that nice name like GCP Meetup or whatever. That kubedns has a deep integration with Google DNS as well. So you actually replicate these services that you create onto your DNS provider automatically. So we go back to the actual console. And we go to network services, DNS, which I should have talked about this, but sorry guys, I skipped it. So yeah, this is my zone federation, and this is my domain name, infrastructure as code for the win. So I go back in the federation. So here's the DNS entry. So if you can see, if I can zoom in here. So yeah, so here's the global, like these are entries for each individual one. So like there's one for Asia, there's one for Europe, and then there's few ones for US. And if you create a one global service, it'll actually create your global a global domain, which would be .global or something. I'll give you a-name records for all individual services in the cluster. So you can actually point to DNS if you want to use DNS. But then IP is much better because, that's DNS and it's a-name records, and there's, health, in terms of health checking, like you'll still be round robining between the records. So it's better to have one global IP and have like one a-name record for that. And then that's all your clients use basically. Yeah. So this is, by the way, you don't have to set, this is like inbuilt. So all you have to say while you create the federation API, this is my DNS zone that I want to control. And then you do the magic and it just does that. And there's ways of like customizing these names so that they're not that ugly. You can actually change it to whatever you want basically. Anything else? This is super futuristic. I know no one's going to do this at work. Please don't do this. I blew a lot of money running all these clusters. So, my paycheck is going to be pretty shitty. Okay, anything else? Okay, thanks, guys. Thanks for coming.
That was great, guys. It was such a good presentation and like showing off all that demo. Amazing. Thanks a lot. Thanks for you guys for coming in.